Okay. For today's class, let's begin with the PowerPoints here. Okay. So let's continue learning chapter 8. On Wednesday, we have already finished the introduction for the conceptual part, the general ideas about what quality is. And about the quality, actually, we also discuss the 8 dimensions of physical goods, the 5 dimensions of services, and we also discuss about the quality at the source, that term, and then we discuss the cost of quality. So we actually have already finished all the introduction for quality, what quality is. And today we will continue learning to philosophy and the TQM and Six Sigma, and we will begin to the process capability. And I mentioned on Wednesday we will have in-class practices today, but considering the change. So I will move the in-class practices next Wednesday. Okay, so let's begin with the two philosophy, the TQM and Six Sigma. So about the TQM, actually, this is kind of a philosophy to help managers to manage the quality. And this all they have 8 principles, different the textbook or different the ideas. They just have the different way to classify the TQM principles. Some of them just have, this is based on the ISOs, this is the 8 core principles of TQM. But in general, TQM is not a tool, it's not kind of methodology, it's kind of a philosophy. So the philosophy to help to give you some ideas and thoughts and methods to help you to just manage the quality. In the ISO's core principles of TQM, actually they integrate the very great the quality managers, the rules of quality management. They just integrate their ideas together and to just some, okay, if you want to manage your quality better, here are things you can take into consideration. Here is some references you can think about. So this is the 8 principles, and we have if I just give you a summarization about these 8 core principles, actually they focus on 3 main steps and other tools. So those 3 main methods or the 3 main kind of thoughts, actually we have already learned. So for example, the customers. So in chapter 2, we discuss when we discuss the operation strategy, we actually discuss customers or not. So we know the customers are really, really important. We should understand our customers. We should understand what they need, what they really want. We should improve the satisfaction and so on and so on. And this is also one of the things we need to be very careful, when we would like to manage the quality better, because the customers is very important. And another part is about another important partners, which are your employees, your people. So in chapter 3, we discussed the people. We discussed you should invest the people as the most valuable assets in your company. And when we mention, okay, we want to cultivate that culture, we want to have an empowerment culture, we want to value our people, we discussed the leadership style, which we mentioned the leadership style should be coaches, not commanders. So leadership is also another thing here, when we want to manage quality, you need to consider about, as well as the people. So involvement of the people, we should kind of enlarge the responsibility of them. We should engage our people. We should give them the power. This is also the things we discussed on Wednesday, the quality at the source, right? And the last thing is what we just learned for chapter 7, and we also discussed on Wednesday. So the continuous improvement. This idea actually comes for the Ever Deming. So this is PDCA, it helps companies to do continuous improvement. So continuous improvement is also another important stuff, like another important like matrix of called TCOM. So in sum, if I like to give you something like what TCOM is, I like to give you this wheel. So the TCOM wheel, and you can find like in the middle of these wheels, we have three things. We have customers, we have employees, we have continuous improvement. So in general, this is like the main stuff we need to focus on when we apply TCOM. Okay, and except for these three important stuffs over there, we also have other tools like on the sides of this wheel. So we have service product, we have process design, which we just learned like for the chapter 4, chapter 6. If we back to like the 8 principles here, they actually talks the similar stuffs. So we need to manage the process instead of manage the functions. We need to make our decisions based on the facts. So we need to have some system approach to help us manage it. Like we need to do some like the benchmarking stuff. So we need to just like help to design the product better. We need to have some tools to help us to make the decisions like the chapter 4 when break even. Break even is kind of like decision making tools. And at the same time, we also need to focus on suppliers, which is also one of the important partners in your business. So in general, actually TCOM just gave you some like the ideas or the principles which can help you to manage your quality. So TCOM in sum is kind of a philosophy with some main principles to help you to manage quality. This is what we have. And if you feel like it's so hard for you to remember all the 8 principles here, consider these wheels. So in the center of this wheel is actually the 3 things. You can forget everything else, but please remember those 3 things: your customers, your employee, and continuous improvement. Okay, so they are the main parts of TQM. Now let's move to Six Sigma. So about Six Sigma, this is another philosophy of quality management. So in general, like when we mention how to manage quality, we have these 2 important philosophy, the TQM and Six Sigma. So Six Sigma is kind of a data-driven approach. So you need to connect your data, you analyze your data, you apply like different like the methods or the math models to help you to get some ideas about your quality and get some ideas about how to improve it. So Six Sigma is data-driven approach to achieve, sustain, and maximize the business success. While the key factors of Six Sigma is minimize the defects. And how to minimize the defects? Reduce variability, which means reduce the variations. So if you think back to the lean operations is to reduce wastes. And now we focus on Six Sigma. Six Sigma is reduce the variation. So this is the main logic for these 2 different stuffs, okay? Lean operations, reduce wastes. Six Sigma, reduce variations, okay? And about Six Sigma, because we hope to reduce the variation. So actually we consider, we need to analyze what kinds of like variations like in your business you may meet or you may need to improve it. You may need to fix it. So in general, we have 2 different variations. We have common cause variation and we have special cause variation. And for this class, like the main tools winner, the control charts, we focus on to identify if there is any special cause variation in your process or not. Okay. And now let's give you a detailed explanation about what does mean common cause variation, what does mean special cause variation. Common cause variation is the variation which cannot be identified. What does that mean? So I give you examples. For example, my remotely controller, I don't have that on my hand, but you know, like the knickers. So when the company produces the knickers, they have different metrics. They need to measure it to make sure like they have the qualified the products. They are not the defects. They are the the units they can sell to the customers. So they may have different metrics. One of the metrics they take into consideration is the weight of the connector. So then they just start to measure each unit they produced. Some of them is 0.5 pounds, some of them is 0.51 pounds, some of them is 0.49 pounds. So even like they produce the connectors, but because like when they measure it, they found like they have some kind of like differences among the weights, among the units in terms of the weights. So, but we still feel like they are qualified because based on their specification, limits, they found like for any connectors, if the weight between 0.45 to 0.55, good one. So the good units are ready to be sold to the customers. So when they measure it, they found like some of them is 0.50, some 0.51, 0.48, 0.52, and then 0.50. So they just found like the difference. Those types of the variation is what we call the common cause variation. It happens because of the current technology you have, because of the current machines you apply, the materials you use, the equipment you apply, the tools you apply. So this is based on the current, like the situation, like what you can produce. We know the variations exist everywhere. Like even it seems the different stuffs, like it seems exactly the same, but if we measure it, we may find this kind of like slight variations, and those types of the variations are accepted. So this is what we call common cause variation. Because of the materials you apply, because of the equipment you apply, it's purely random and unidentified. So this is what we have, what we call the common cause variation. This is not what we need to focus on. This is what you can improve it, but in general, you may need to make a big investment to improvement to change your equipment, or maybe to just because of the development of the technology, you can reduce it. But this is not the variation we focus on to improve it in terms of quality management. What we focus on to improve the special. We want to identify if there is any special cause variation and to improve it. This is the Six Sigma. When we want to reduce the variation, this is what we mainly focus on, the special cause variation. So this is something we can identify it. It is happened because of a mistake or because of like a reason, a causes you can find it. For example, just like still the connectors, we measure the weights, then we find, okay, 0.51, 0.49, 0.50, and 0.48. And the fifth one, when you measure it, is 0.05. Then you probably find, okay, 0.005, like compare with those, the differences is too big. And after you check it, you find actually it's not 0.05, it's actually 0.50. But because of the employee who take the notes with the weights, they just like have one more decimals over there. So they just write down it by mistake. So this is kind of like the variation, what we call special cause variation. It's caused by a special reason and you can identify it. So this is what we call special cause variation. So in general, special cause variation is something you can identify and you can eliminate it in nature. You can fix it. Okay, so those two different variations, the common cause variation and special cause variation. This is like based on the Six Sigma, what we want to reduce it. Okay, any questions by now? Because it's a virtual, like the video, so I'm so hard to I cannot just receive your feedback directly. So if you have any questions, just just speak out, just like chat in the, just send me a message like for the chat box if you want. Just let me know, okay? Anytime if you have any questions. Okay, let's continue. So this is what we mentioned, the different variations. And now the last thing I'd like to introduce for you is about the Six Sigma certification. So this is actually a really useful certification. Like if you want to find a job as a project manager, the PM, or the quality manager, or the operation manager, supply chain suppliers. So if you want to find like the job in in this areas, the Six Sigma certification is really useful. And we have different level for that certification, for the white belt to MBB, which is the master black belt. And in general, like I recommend, if you want to take that certification, I recommend to have the green belt directly, so you don't have to begin with white belt. After you finish this class, you have already mastered actually the yellow belt stuffs. The yellow belt means like you aware the Six Sigma principles, you know them, and you don't have to like finish the projects alone. Actually, you can just like follow some people like to finish one of those projects like in this areas. And for the green belt is like, except for like you know what Six Sigma is, you also have some like the knowledges to deal with the questions, to deal with the projects. You have some like the ideas about the some tools, the decision making tools. Like one of them is what we will learn, CP, CPK, and others. So if you know them, like you know how to solve the questions, how to analyze those like based on the data you have, to analyze the quality stuffs and the supply stuffs, you will be ready to take the green belt. And currently we have different like organizations to help you to like just like earn the Six Sigma certification. We have 3 different organizations, so you can choose either of them. And actually, like if you feel interested in the Six Sigma certification, please feel free to reach out to me, because as far as I know, like currently, like the cost for this Six Sigma certification is kind of like around 400s. So if you feel interested in it, please feel free to reach out to me. I'd like to help you, like just provide you necessary trainings, and we can just like to apply for the fundings here in the business of school to cover the cost of this certification. Okay, so just let me know if you feel interested in it. And now this is actually the main part for today's class. So now let's learn the first 2, the process capability. Okay. Process capability, we will learn 2 different terms. We will learn CP and CPK. So both of them are the ratios of process capability. So process capability, the first thing you need to figure out is the objective for this tool. So for any tools we learned, we want to apply it to help us solve some questions like break even. We want to make a decisions about like if make money for this new product designing, or we should make or we should buy for the supply directly. So we just like apply the difference, like the tiers, like when we learn the flow chart, help us to visualize the process. And now for the process capability, the CP and CPK, we wanted to figure out if the process you have is capable to do something. So when we design a process, we want to produce something. So we have a whole process over there, and we have some specification. So we want to produce the clicker, we want to produce the pencils or others. So you have the ideas about what you are going to do, what's your main objective of the production. And these 2 ratios will help you to analyze, okay, your process you design this process and you have that process. if this process is capable to finish your objectives. So this is what we focus on here. Process capability, the main logic, the first thing you need to figure out is the objective of it. So it helps you to analyze if your process is capable to meet the design specification for a service or product. Okay, and now the next thing is like we need to know how to do it. How to do it. Before that, I'd like to introduce you several terms here. So the first term is what we call nominal value. So the nominal value is also the target value. For any specification, you probably have like the target values of like anything you want to measure. It's just like the clickers, the weights. Probably like sometimes we have a target value of 0.5 pounds. So this is your target. This is what you want to achieve. You hope you want to like produce each unit with 0.5, but we know like the variation exists. So probably some of them is below or above this numbers. But anyways, the first thing you need to figure out is your target value, the nominal value, 0.5. And then we probably have like for any specification, like we have a tolerance. So the tolerance is like actually an allowance above or below the nominal value. So this is what's the range. The range, if that you are still accept. So for example, like we have the tolerance is plus minus 0.05. So it means any clickers, if its weight above 0.05 or below 0.05, they are still qualified. Okay, so this is what we have the tolerance. And based on the nominal value and the tolerance, you will have upper limits and lower limits. So this is what we call upper specification limits. Upper specification limits, it equals to what we have for the nominal value plus, because this is above, so plus 0.05, then we have 0.55. And we have the lower limits, the lower specification limits, which is 0.5, the nominal value, which is your target value, minus 0.05, then we have 0.45. So your lower limit is 0.45, your upper limit is 0.55. This is your specification. So when you design something, you have your target, you have a range for it, which is what we call tolerance. Okay, so this is for this clicker is 0.45 and 0.55. Now let me ask you, so what if I have a clicker when I measure it is 0.41 pound? How is it? It's good or not good? Not good, because it's below the lower limits. Okay, so if you figure out those three terms, like those three numbers, we are so close to calculate the CP. So when we calculate the CP, we need to understand what does it mean it's capable, what does it mean it's not capable. So the process is capable means the green line here, this green line is what your real distribution. So you connect all the data. So you just measure each unit of the weights, and you connect all the data and they distribute. Then you consider the standard deviation. Then you have that distribution looks like this green line, this curve. Then you find all the curve, all the green line, they within the upper and lower limits. So all the distribution, each of the units, you measure it, they are within the limits. So all the distribution within the limits is capable. Otherwise, if you find something outside which is above the upper limits or below the lower limits, it means your process is not capable. Okay, so this is how we measure it, how we get some ideas or the conclusions based on the results you have. So for this process capability, like the figures I gave you, probably you have that ideas. So how we measure the process is capable or not capable, we consider two things. We consider the real distribution and your limits, right? So, and the differences between the upper and lower limits. So this is what we also call the specification. So when we want to use process capability, the CP or CPK to measure it, we consider these two things. We consider what is your real distribution and what is your specification limits. For the specification limits, we use this one. We consider the upper limits, the differences between the upper and lower limits, which is your range, your tolerance, right? And for the real distribution, we consider sigma. Sigma is the standard deviation. So this is how, based on the data we connect, we know the real distribution. We use sigma to represent that. Okay, any questions here? Again, then let's move to the next, how to compute CP. So for the CP, it's equals to, we use the specification limits. So CP here is actually what is your acceptable range, which is your specification difference, divided by the actual the actual distribution. So this is what we have, sigma. Then it equals to the differences between your upper specification limits with your lower specification limits divided by 6 sigma. Okay, so this is upper specification limits, lower specification limits divided by 6 sigma. So we compare these two things. The CP is actually a ratio to represent if your process is capable. And how we know that? Then when we have okay, so here we go. So we need to compare CP with number one. Number one, what does that mean? So we just have that ratio. We use the specification limits and the distribution. So what if the acceptable, which is your specification limits, larger than the actual distribution? So if you have your limits is larger than the real distribution, then you will have CP less than 1. For example, if the acceptable is 4 and the actual is something like less than 4, oh, sorry, it should be larger than 1, then it means all of your real distribution are within the limits you have. So your process is capable, okay? Otherwise, if you have your acceptable less than the actual, then your CP will be less than 1. So your real distribution will be larger than the limits you have, your CP less than 1, then it's not capable. So for any CP here, it means that it equals to the absolute value between upper specification limits and lower specification limits divided by 6 sigma. And if CP larger than 1, larger or equal to 1, it means capable. Less or equal to 1, it means not capable. Actually, if it equal to 1, it will looks like this. It just like just within the limits. Okay, so this is CP equal to 1. It's just within the limits. So we prefer some CP's value above number 1, then we feel, okay, your process is capable. Otherwise, it's not. Okay, super straightforward. This is what we have. And what I gave to you, like based on the specification limits and the sigma, which is the distribution, is what is the logic behind these formulas. But if you want to compute the CP, here we go. This is the formulas you need to figure out. Okay. Any questions? If you're good, let's take a look with example. Okay. So suppose that design engineering team set the specification for length of a staple sheet metal part at 10 inches with acceptable tolerance is 0.05 inches. And the average length of the products produced by the actual stamping process is 9.99 with a standard deviation of 0.015. Okay, so what is the CP? And how this process, is this process capable or not capable? Okay, I gave you kind of like a few minutes to digest the information, and I have a couple of questions for you. Okay. Okay, let's talk about that together. So if we know that CP equals to the absolute value, the upper minus the lower specification limits divided by 6 sigma. Now, what is USL? What is the upper specification for this problem? Ten point five. 10.5. 10. So what is 10? 10.05. Okay. What is 10? 10 here is, what does it mean? The specification for length of a staple sheet metal part at 10 inches. What does it mean 10? So I gave you like several options. 10 is the nominal value. Option A, nominal value. Option B, USL. Option C, LSL. Which one? I saw Emily and Hayden feel like it's nominal value. How about others? Nominal value. Okay, so 10 here is the specification target. So they want to produce this part, like for each of them, they target with 10. So 10 is the target value, or we call it the nominal value. And now we know the tolerance is plus or minus 0.05. So the upper limits will be the target value plus 0.05, which is 10.05. While the lower limit is 10 minus 0.05, which equal to 9.95. Now you already get the upper lower limits. 6 is the constant, so you don't need to care about that. You don't need to compute that. It's always 6. What is sigma? So sigma is 9.99 or 0.015. Let me give a pause over there. So it's really funny. So sigma is 9.99 or okay, so have you received a poll? Is the sigma is 9.99 or 0.015? We have 3 students choose 0.015. How about others? Okay, 4. Any people feel it's 9.99? Okay. Okay, I received like half of the like fail is 0.015. Yes, so 0.015. Then what does mean 9.99? This is the actual stamping process. So this is the actual average. Actual average is 9.99. So we use mu, and you will need this nature. Okay, once we like do the CPK nature. So for these questions, we have the sigma is 0.015, then we will be able to know that. So the CP is 1.11. Now my second question, is this process capable or not capable? I am holding another pause for you. Okay. You probably received like another questions here. It is capable or not capable? No? Yes? I have 1 no, 1 yes. 2 yes. 5 yes, 6 yes, 7 yes. Tana, you can just chant in the box, or you can just give me a thumb. You don't have to. Okay. Okay. Okay, it should be yes. why it is capable? Because like when we have the result of CP, we need to compare CP with number one. If it's larger than number one, yes. If it's less than number one, no. If it equal to number one, it's just like in the within the limits. So it's not that good, but it's still acceptable because all the distribution within the limits. So this is what we have for the CP. Okay. Any questions? You good? Then let's do so I will stop like introduction here. We will continue learning the chapters like the CPK nature. But now I have a question for you. For these questions, you only need to focus on the CP. Okay, you don't have to care about CPK. I'm just like asking you to compute the CP. Okay. So this is like Webster chemicals, and you don't have to submit that, but I will share with you like the results. Okay, so I give you like around 3 to 5 minutes. Then let's take a look how to do it. Actually, I gave you the answers directly. So if you find that so the first person like who inserts first three person like who insert your answers in the chat box or give me, then you will earn sticker. Okay, Emily has already got the answers. So 1 more minute and then let's just do it together, okay? Okay, so for these questions, we still need to find CP, and CP equals to the differences between the upper and lower limits divided by 6 sigma. And the upper specification limits equals to the target here is 8, and with a plus or minus 0.6, which is the tolerance. So the upper limits will equal to 8 plus 0.06, which 0.6, which is 8.6, while the lower limits equal to a minus 0.6, which is 7.4. So this is what we have, and then we will be able to know, okay, it's equals to 8.6 minus 7.4. We take the absolute value into consideration, divided by 6 times sigma. And sigma here is the standard deviation, which is 0.192. And then we have, okay, should be 1.2 divided by 1.152, then we got 1.04. 1.04, which is larger than 1, so we feel it's good. But take a look here. So the target process capability is 1.33, so it's not that good. It's capable, but it's not achieve the target process capability. Okay, so this is about the CP. Any questions about today's class? I know it kind of like online, so we probably not that. I mean, let's review it like next Wednesday. Okay, so if you have any questions, feel free to let me know. Okay. Okay, I hope you have a wonderful weekend and stay warm. Okay, it's so cold outside, so stay warm and have a wonderful weekend.